Alright, welcome back to Acorn's Academy. Today we are going to wrap up our discussion of substitution and elimination by talking about the E1 reaction. Last time we talked about the E2 reaction. Today we are going to talk about the E1 reaction. Alright, so let's do this. Starting off the way that we always have, we're going to first look at the name, and again the name can clue us in on some ideas here. The 1, just like in SN1, correlates to the fact that this reaction is unimolecular. Okay? The E here is elimination. Okay? This is an elimination reaction. Now, just like how we said that the E2 reaction and the SN2 reaction have a number of similarities, the E1 and the SN1 reaction also have a number of similarities. Okay? And as we fill out our table, we're going to recognize and become very familiar with these similarities. Okay, so let's go ahead and analyze our reaction scheme here. We have this alkyl halide. Now I want you to think for a minute what kind of alkyl halide we're working with here. We are working with a tertiary alkyl halide. Okay, this is a tertiary alkyl halide. Okay, so I have this tertiary alkyl bromide, and as usual, I'm getting my alkene. Okay, with an elimination reaction, we can actually predict our product. We will be getting an alkene. And my reagents here are just methanol. This is CH3OH. And this delta symbol, it looks like a triangle. This delta symbol, this signifies heat. So I'm using some heat here. Okay. So I'm going to make an SN1, SN2, E1, E2 summary video in a little bit. And that's going to kind of help clarify a little bit of what we're observing here. But for now, I want you to understand that heat usually suggests elimination. Okay? Both for E1 and for E2. We didn't really talk about it in E2. Again, we will. But for the purposes of today and henceforth, heat usually implies elimination. Okay? We're usually going to be forming some double bonds. Okay. You'll also notice that for E2, we needed a strong base. For E1 here, we have a base, but it is a weak base. Okay, this is a weak base. All right. So let's take this knowledge and let's go ahead and fill out our table. We'll get to this mechanism in a minute here. You can notice we are almost done with the table. This is the last bit we have to fill out. All right, so kinetics, I'm going to start with kinetics. We said unimolecular. The substrate, just like SN1, we said is very similar to SN1, so the substrate here is also bulky. Okay, tertiary. Bulky substrate. Nucleophile base strength, again, this is elimination, so we're going to be using a base, and we're going to be using a weak base. Okay. Weak bases often include, honestly, very similar to the nucleophiles. We have water, most alcohols, we can have ammonia derivatives, NH3, and so forth. These are some weak bases. Stereochemistry is interesting. We're able to end up with a mixture. Okay, we are able to end up with a mixture here. And the last thing here, solvent type, this is polar protic. Okay, so just like SN1, polar protic. Now, you may have recognized that there are a lot of similarities. Basically, almost this entire table is the same. Mechanism I said we'll get to, but you can predict just like SN1, this is also stepwise. We can recognize that a lot of this is the same, right? Same substrate, same solvent type, same mechanism, same kinetics, even the nucleophile and the bases. Most of these weak bases also happen to be weak nucleophiles, right? And you can observe that here. They are very similar. So these two are going to be pretty fiercely competing reactions. Okay, so now that we kind of have a little bit of a generic idea of what we can expect, let's get into the mechanism. So as always, with any SN1 or E1 mechanism, the first thing that's going to happen is the leaving group is going to leave. Okay, this leaving group is going to leave, so I get a Br minus. And just like with SN1, I end up with this carbocation intermediate. Okay. Now also just like SN1, this is the key step. Okay, forming this carbocation, that is that key step. I'll label this step 1. Okay, that is a key step in the formation of this eventual alkene. Okay. All right. Now with SN1, we would have our nucleophile attack this carbocation, but with E1, what instead is going to happen is the lone pairs from the oxygen of this methanol molecule, they're going to come in and they're going to pick up the proton, and we're just going to form that pi bond in between our alpha and our beta carbons. Okay, so we end up with a product that looks like that. I guess the side product here is MEOH2+. Okay, so a couple of things to note here. When it comes to the hydrogen, you may remember for E2, we said that it had to be beta antiperiplanar. For this one, you do not need beta antiperiplanar. Okay, we do not need our hydrogen to be on the opposite stereochemistry. Okay, the reason for this is that because we're forming this carbocation intermediate, right? Because we have this intermediate here, we can just eliminate any proton. Okay, this is a stepwise mechanism. It's not concerted. I don't have to think about the stereochemistry of the bromine and the beta hydrogen too much. Okay, I just gotta eliminate a beta proton. Okay, the beta is like the key thing. Actually, I'll label that up here as well. Now, the other thing we said about this was mixture. Okay, mixture. Sometimes you end up with a mixture of products. And that oftentimes is the result of resonance stabilized carbocations where we have multiple proton options. So I'm going to go ahead and draw an example here. Okay, I'm just going to go ahead and do something like this. Okay, so maybe that's the alkene we're working with, okay, or the alkyl halide. So if I treat this with, let's say, I don't know, water. Okay, let's just go with water. The first thing that's going to happen is the bromine is going to leave. And so what I end up with is this carbocation, but this carbocation is resonance stabilized because I can draw a resonance structure that looks a little something like this. Draw that there, that goes there, and then that goes there. Right? So now my carbocation is moving throughout my molecule. I don't just have one carbocation, I have an entire delocalized set of this positive charge. It's spread out. So I have some options here, right? If I were to take this example, right? I'm going to change colors here. I'm going to draw out my available beta protons, okay? I could eliminate this proton. I could also eliminate this proton. Okay, I have options there. I cannot eliminate that proton. Okay, I can't do that. That's not an alkene. Right? Here I can eliminate this proton. Okay, with this. So because I have these options, I'm going to end up with a eventual mixture of products. Okay, so I'll go ahead and actually draw them up here. If I label this as 1 and I label this as 2, then I can get a couple products based off of the resonance structure 1. If I eliminate this top proton right here, if I label that as H1, if I eliminate H1, I'm going to end up with something that looks like that. Okay, that pi bond is like sticking out of the ring. If I eliminate H2, I'm going to end up with something that looks like that. Okay, and then if I come here and I eliminate H3 on this second resonance structure, I'm going to end up with a product that looks like this. So, as we have seen, based off of this single resonance stabilized carbocation, that I can end up with a mixture of products here. Okay, I can end up with multiple products. These two are from resonance structure 1, this one is from resonance structure 2. And so in that sense, E1 is a little bit more complicated and a little bit messier than E2, the same way that SN1 was a little bit more complicated and messier than SN2. Okay, so I'm just going to label a few more things here. This is a mixture of products. And this is something you do need to watch out for, because a lot of professors like to put resonance stabilized carbocations on exams, and then they'll have instructions like draw all of the products. Okay, in which case you'd have to draw all 3 of these out, because they are all viable products. All right, so I think that just about covers everything that we had to talk about for E1. And that also covers everything that we had to talk about for these first 4 reactions. So the next kind of set of videos that I'm going to make are going to be some additional considerations to keep in mind for the substitution and elimination side. And then I'm going to make a summary video where we compare all 4 of these reactions and we go through some very common exam style questions to help you feel prepared. So if you enjoyed this video and found it helpful, please do leave a like. I'd also love to hear your feedback on anything you'd like to see done differently. And I look forward to seeing you in the next video. Take care.